Hello, all the prestigious personalities. This is me, Aryan Kumar, and today we are going to study about all measuring errors and uncertainty basically, not certainty. Like I have already cleared that in my theory that how to calculate or what formulas are used for error or uncertainty. I will simply derive equations today. I will just try to focus upon numericals today, examples, and cover that out. If you haven't checked that out, like the video explaining the concept behind it, what are errors and what are uncertainty, you can just go through it. You can search like error and uncertainty on my channel, and a cursor down there, you will find that video. Anyway, we are just talking about uncertainty and errors today. Now, there are a lot of, you can say, instruments or physical weapons, like physics, in physics term, that is called a weapon, but in actual it is instrument. We utilize a lot of instruments in our daily life to calculate any numerical value, or you can say any value based upon meter, centimeter, diameter, etc. Okay, if I talk about any certain example, that would be sorry for my very bad drawing, but this is somewhat a vernier caliper looks like. Um, I'm really sorry for that. Uh, okay, so this calculates somewhat, uh, you can say, any type of, uh, you can say, size in centimeters, and you can say 1/10th part of a centimeter. Meanwhile, as I talked about any uh, any further clarification of any instrument, that is screw gauge exactly, that tells us about 100th time of times of centimeter. Okay, so these are few of the instruments that we normally use in our daily life. Sorry for the bad example of vernier caliper. Anyway, uh, where what is the formula? Like, if there's any type of spherical shape, like a spherical shape, if I just draw somewhat a spherical shape, you can just imagine it. Okay, a spherical shape. If I have to calculate the diameter of it, the size, the volume, etc., then I'll utilize formula. But before formula, there are instruments as well. But further clearing it out more, we will utilize the formulas. Now, what are the formulas that we utilize at major? Like, suppose this is a sphere. Okay, sphere. Let me just color it out. Okay. Now, suppose this is any type of sphere shape, basically, and I have to calculate its volume. The simple formula that I will utilize is 4/3 of pi. Okay, as I'm talking about a sphere. Okay. So pi and its radius with its square. Now, if there's a situation in which you have to define the radius of any circle, you will simply do a thing. You will put your value in here and you will find it. For example, you have to find the radius of the circle. The first step would be to find, like, we will initially look at it then, but if I have to find the radius of this sphere and the radius is 9, I simply put the my value, like the value 9 here, and square it up. It is 81, I believe. Yeah, it is. So that simply gives me my my answer of a radius. That is quite simple. Again, we have to do calculations, all the thing that happens here. Now, how do we get this thing? Now, if I talk about volume, delta volume, and volume that I just talked about my in my recent video, and multiply it thrice by the delta radius and its radius itself. That is my first step of solving any type of numerical that is essentially asking us something about maybe measurement of any type of diameter, like any diameter of anything, any object, that can be a sphere, that can be any type of shape. You can just imagine that, right? So I'll simply get this equation by a derivation that is not normally available in our book. You can eventually search for that derivation as well. Okay, Now, that's how we do the first step. Then whatever the value we get, for example, v equals to something around 9. Okay, I'll do a simple thing that at first multiply, like do this whole scenario, put my values and like solve it. For example, 3 multiply by maybe 0.2 multiply by the radius 9, that will initially give me somewhat a value of 0.067. And initially the 0.067 would be my first answer. That will be my, you can say, diameter of the whole scenario that we are calculating. And later on, when I will just calculate the radius, that is my second step. Okay, at first you have to calculate the diameter, and for calculating the diameter or volume, you will utilize this formula. For calculating the radius, you will utilize the formula that I just told you at the start of the video. Volume of anything equals to 4 of the third pi, that is half circle. If you know, if you are mathematicians, or like not a mathematician or a student, I can say you can definitely understand that. Okay, if you love mathematics that much. If you don't, it's okay, I will just teach you. 4/3 of n pi, that is half circle, indirectly a sphere, and doing a square of it according to our value. Now our value was 9. I just will put 9 here, just calculate it and have my final answer. Okay, so that is how you calculate any type of measurement, or you can say uncertainty, or um, yeah, uncertainty of any volume, and later on calculate its radius. I have already thought about what are errors in actual, what is uncertainty, what are its type. No, like all of that. Okay, okay. Let's just talk about anything that is again important for us. Let me just clear up this. All right. So when we did the first step, we were initially doing something like finding a volume, but indirectly, if I'm finding a radius of anything, that is a volume as well. But how will you denote both the things, like separately or distinguish between them? At first, you calculated the error of the question or equation. Okay, for finding an error, you utilize the first step that I told you. Later on, the step that I told you was to find an absolute value. So if it is like somewhat, if the v is given as well, v is 3, okay, like 3, and my delta r is a given value that is 0.3, and something like r square that is 9, that will give me any value that is my volume, and the volume will be my error of the equation. Meanwhile, the answer that will be provided by the equation number 2 by solving my radius square, that will give me my absolute value of a error. If you don't know what is absolute value, what is a error, again, I suggest you to look up to this, uh, and just try to understand the concept what actually it is. Anyway, let me just clear it up and try to understand or tell you more concepts. Okay, now there are a lot of other terms such as fractional uncertainty. Okay, fractional uncertainty. I will just type a short form of it. That is fractional uncertainty. How to find that? Like, what is a fractional uncertainty? Basically, anything in a decimal value is called so-called, uh, you can say, fractional value or fractional uncertainty. How will I calculate that? First of all, you will have to put your uncertainty as your numerator, okay, and your denominator will be value for weight, like whatever the weight of the sentence says. For example, in a sentence the constant weight is 60 kg. Okay, I'll simply put 60 here, and for suppose my uncertainty level is maybe 2, I'll simply divide that 2 and the 2, 2 3 is 6, and will have an answer in a decimal value. That is how I calculate a fractional uncertainty, right? And what if I talk about how to find a percentage, how much uncertainty it is in a equation? or in a question you can say, okay, so you have to do somewhat a similar function. Okay, if I say like uh, percentage equals to um, uncertainty area numerator again, and the kilo weight, or you can say not kilo weight, a constant weight as your denominator, and multiply that by the number, not the number, by the percentage of 100. You will initially get your answer as something, some number, for suppose 2 as your percentage, and that will be your uncertainty of your question or whatever the thing is asking, right? So these are few um, additional things that I thought that I should teach you. Again, practice myself as well. That's it for today. Thank you for joining me. I hope to see you in our next video. Bye bye.